Greetings, my wonderful scholars. How are you doing today? We are still on calculations on equations of motion. Making calculations on equations of motion. Today's question says, a ball of mass 0.8 kg is dropped from a height h just before striking the ground. Its velocity x 5 meters per second. Determine h. A certain ball from height h is dropped. Then as the ball is going down, before the ball hits the ground, it makes maximum speed. Its highest speed before hitting the ground was 5 meters per second. Then calculate the heights. Okay, this question is under motion. Then recall, anytime we notice a particular question that can be solved with equations of motion, first of all, enlist your equations of motion. Let's do that. Solution. Let's give ourselves that confidence that we can do it. Okay, let's get our parameters. We were given mass 0.8 kg. Okay? Then the mass was dropped from height h. That's what we're asked to determine. We're looking for h. Just before striking the ground, its velocity, then v, the final velocity. Hey, there is a puzzle we need to solve here. Anything from height, its initial speed is 0. Before a body begins to drop, you will hold it. So the initial speed is 0 meters per second. Then the final speed is that biggest speed before it hits the ground. Because as the body is falling down, the speed is increasing. So the final speed is the speed it attains before striking the ground. And that's the maximum speed of a falling body. Okay, so that maximum speed of the final speed is 5 meters per second. Whereas the starting speed of the initial speed is 0 meters per second. When you fail to bring out that initial speed, you'll be having difficulty with your equations of motion. So never forget, a falling body, its initial speed is what? 0. Every falling body has initial speed of what? 0 meters per second. Okay, let's observe the parameters. Okay, when you observe the parameters, then go and list your equations of motion. The first one says V is equal to U plus AT. The second one says V square U square plus 2AX. Third one says X is equal to UT plus half AT square. And the last one says U plus V over 2 times time, average speed times time. Okay, those 4 equations on the board. With time, we expose certain skills you must know. And one of them I will expose today. Anytime a body is falling from heights, there is a particular formula that will favor. When the body falls down from a certain height, you go for the equation that is 3 on the board. Equation 3 on the board. I call that equation Galileo's formula. Galileo's formula. It was Galileo Galilei that gave the world that equation. Equation for falling bodies. Anytime a body falls from height, use Galileo's formula. Let's get it separate. X is equal to UT plus half AT square. Galileo's formula. Okay, recall initial speed is 0. Therefore, what do? 0 times time will be 0. Then X is equal to, since U is 0, anything times 0 is 0. So this part is out. So the equation will be reduced to half AT square. Half AT square. Then recall, the body was falling due to gravity. Anybody release and the body makes free fall, that body is accelerating due to gravity. Therefore, our A will turn to G, acceleration due to gravity. Then X is height, the distance covered or the height covered. So we change the letter H to capital H. Distance and height are the same. Okay. H is equal to half gt squared. So this is the formula we'll be applying. That's the formula for falling bodies. Galileo's formula. Galileo's formula. H equals half gt squared or half at squared. Okay. Then we solve. H equals half times acceleration due to gravity is a constant for Mother Earth. Every planet has its own g. That of the Earth is 10 meters per second square. That of the Moon is 1/6 what we see in the Earth. 1/6 of 10 meters per second square is acceleration due to gravity of the Moon. But we are in the Earth, of course, so we'll be using 10 meters per second square. 10 g is equal to 10 meters per second square. Anytime a body is falling, g is constant. So whether given or not, you should bring it out. G 10 meters per second square times t square. Okay, in our parameter, there is no time. Then notice we didn't use the mass. Mass there is a distractor. Here we are not concerned with mass. If we want to involve mass, we'll be going to dynamics. This is still kinematics. We are talking about motion without making reference to what is causing the motion. So we are neglecting mass. Because mass can bring in the idea of what? Force. Mass cannot change to become weight. So we ignore the mass. This is still kinematics. Okay. You can see we have two unknowns. We don't know the heights. Neither do we know the time. So we'll play smart. We'll go back to equations of motion again to see how to get time. Let's see the possible equation that will give us time. Because we need time to complete what we're doing. This is the actual formula to solve the falling body. But we don't know the time. Therefore, let's go and find a way to get the time. So let's bounce back to our equations. Then if you notice, the first equation is our result. That's what will help us. Okay, let's see why. We know the final speed. We know the initial speed. We know the acceleration. We don't know the time, so we'll get the time from here. We'll get the time from here. Yeah. We know all these parameters except time, and that time is our target. So let's solve for time. So I'll put other equations away. We don't need them for now. They're out of the game. Okay, I'll be using equation 1 to find my time for the falling body. So what was the speed, the final speed of the falling body? 5 meters per second. The initial speed, 0 plus the falling body, what type of acceleration? Acceleration due to gravity. Change to g. Change it to g. Becomes 10 times t. 10t. Then go on with arithmetics. 10t. Then make time the subject. T is equal to 5 over 10. That is 1 over 2. Then our time is 0.5 seconds. You can see the time it takes for the body to fall from a certain height to the ground. 0.5 seconds. Let's go back to get the height covered. So we've got the time. Then we'll bounce back to complete our solution. Remember, we stop somewhere, we'll continue. H is equal to half times 10 times. Recall our time is 0.5 or in fraction 1 over 2. Let's go back to the fraction. 1 over 2. Never forget, you follow your formula. Go by your formula. The formula states t square, square of the time. That's what Galileo portrayed as the equation of falling body. Okay, squared. Then we go. H is equal to 1 over 2 times 10 over 1. Every whole number has a denominator of 1 times. Then let's go by laws of indices or law of index here. Here we have a fraction. We have 2. Forgive me. Here we have a power of 2. The fraction shares from the power. So each of the term in the fraction will pick its own power. 1 square. 1 times 1 is 1. 2 square. 2 times 2, 4. So that's expressed. We go on. 2 key self 1, 2 key term 5. 1 times 5 times 1, 5. All over 1 times 1 times 4, 4. The height is equal to 5 divided by 4 will be giving us 1.25 meters. 1.25 meters. So in a nutshell, we are saying that if a body is released from height of 1.25 meters, if you release anybody irrespective of the mass, be it a rock, a feather, once the height is 1.25 meters, that body will have initial speed of 0 and final speed of what? 5 meters per second. Final speed of 5 meters per second and time of 0.5 seconds. This is science. You can test it yourself. Anybody falling from height of 1.25 meters, the initial speed is 0, the final speed is 5 meters per second, and the time covered is half second. Half second. Recall, science predicts happening in the natural environment because science understands the pattern of happenings in the natural environment. And this is what we call law, theories, facts, and so on. All those science terms just to describe our environments. Please stay tuned as we go on with physics findings. Do subscribe.